Okay, hi there. I'm Hao. This is just another video of me. So you know, I'm with Code Roland. Today we have a course schedule. So there are a total of num course. You need to take represented from label from 0 to num course -1. Okay. So if it is 3 course, then we have course 0, course 1, and course 2. We are given prerequisite, and the prerequisite of I equal to AI BI indicate that you must take course B, right, before you take course A. Right? So if it is A and B, right, the relationship go like this: B first and then A. Right? Let me just write it down here so we don't forget. B to A. Right. To take course A, you need to take course B first. Right. That is the rewrite. Okay, so I'll return true if you can finish all course, otherwise false. Okay. So first of all, uh, we need to start from the node, right? We need to start to take the course that have a 0 incoming edge. Right. So for example, right, if we have something like this, if we have 0, like 1, right, and then 2 back to 1, right, we have something like this. Um, right. So to take course 0, you need to take course so sorry, so you need to, you want if you want to take course number 1, you need to take course 0 first, right? So that is 0 to 1, right? 0 to 1 here, right? And then to take course 2, you need to take course 1, so 1 to 2. And then to take course 0, you need to take course 2 first, right? 2 to 1. So this is a loop, right? You cannot take any course first because taking one course will require another course, right? So you need to start from a course that have a 0 incoming edge, right? If it is like this, then it is valid, right? For example, like we can start from course 0. Right, let's say we have something like this. Right, let me set 0, 0, 1, let's say 4, 1, 4, 1, 3, 2, 4, 1, 3, and then 2, right? You have something like this, and then like this, and like this, right? Okay, so the equivalent array would be, right, you take code for 4, you took 1, you take course 4, right? 4, 1, and then 1, 3, right? And then 2, 3, 2, right? And then 4, 2, right? So to take course 4, you need to so to take course 2, you need to take course 4 first, right? So that is 42. And to take course 1, you need to take course 4 first, right? So 4 to 1. Right, so to take course 1 and 2, to take course 1 and 2, right? We need to take course 4 first, right? And to take course 1, sorry, to take course 3, we need to first take course 1, right? So to take course 3, you need to first take course 1, and to take course 1, we need to first take course 4, right? The last one is 3, 2, right? So from 2 to 3, right? To take course 3, right? You need to either take course 2 or 1, right? And to take 2 or 1, you need to take 4, right? So remember earlier we have something like this, right? Like a loop, right? Which is not valid. We cannot start at any course, right? Because any course require like some other course, right? Or sometimes we can also have like something like this, right? One and one, right? This is also like not valid. To take course one, you need to take course one, right? But you haven't taken course one. That doesn't make any sense, right? So for it to be valid, right? You have to be able to start from a node that have a zero incoming edge, right? So for example, in this case, it is 4, right? Right, and we can look at the neighbors, right? So this have a zero incoming edge. This have one. This has one. This has two, right? So we need to count the number of incoming edge first before we even start. So after we count the number of incoming edge, we will select the one that start with zero, right? They have zero incoming edge, right? And then what do we do? We just look at the neighbors, right? And then decrement their incoming edge. It is like a form of, it is a topological sort algorithm, right? And when we decrement the neighbors incoming edge, like in degree, right? The incoming edge is also called the in degree, and the outcoming edge is also called the out degree, right? Just a graph terminology there, right? So whenever you start from this node, right? And then you have to look at the neighbors, right? Which is the node, and then decrement their incoming edge, right? And in the meantime, when you process this node, we can add it into our array, right? If we have to, in case if we want to keep track of the course we have taken, right? And then if it is zero, then we're gonna add it to, right? We're gonna start at 4, right? We pop 4 off, and then we pop 4 off, right? So and we look at the neighbors, we decrement the number of in degree, right? And then if it is zero, we add it into our stack, right? In our array, right? To process. Okay. So now we can process one. So we pop it off, right? We process one because one has zero incoming edge, right? Which means now we can safely take the course, right? Because there's no other regret to take one because we already take 4 earlier, remember? Right. So the one, we look at the neighbors, which is 3, right? So we decrement the incoming edge or the in degree. So 2 to 1, right? Because it is not zero, so we ignore, right? And now we need to process 2. We pop 2 off, right? So we process 2, right? We can safely take 2 now, course 2 now, because course 2 have a zero requirement, right? Zero in degree. So there's no other requirement to take course 2. And we already take course 4 earlier. We already processed course 4 earlier. So we can take course 2 now. So we look at the neighbors, right? And we decrement the in degree to from 1 to 0, right? And because it is 0, we're gonna add it to our stack, right? So now we can process 3, right? And then we are done, right? Because 3 doesn't have any neighbors. So you can think about it this way. 4 is the first course we have to take, right? And then we can either take 1 or 2, right? And from 1 to 2, right, we can take 3, right? So to take course 3, we are required to take course 1 and 2. And to take course 1 and 2, we need to take course 4, right? So you can either go 4-1-3, right, or 4-2-3, right? Doesn't matter. Okay, so that is the general algorithm there. I look pretty straightforward, right? But there's a couple of things we have to do to make this work. So first of all, we need to count the number of in degrees, right? In degrees before we start, right? So before we start, the in degree is 0 here, 1 here, 1 here, and then 2 here, right? So we need to be able to keep track of that. Right. So if it is 2 to 4, right, which means we need to take course 4 first before we take course 2. So the degree gonna fall on the 2 here, right? This one, right? So it would be a course A plus plus. So we just have to keep track of it, right? So that is the first thing. The second thing we need to do is we need to build out the neighbors, right? So at each node, we need to be able to look at the neighbors, right? So for example, at course 4, right, we need to be able to look at course 1 and 2, right? So in other words, the array given in the prerequisite, that is that is the edges, right? Whenever we are given the edge, we need to build out the adjacency list. We are like the neighbors, right? And so for example, at 4, right? At 4, we can look at 2, right? 1, 1, 4 again. 4 is already in the neighbors. So we just append 1, right? Similarly, 1, right? 3 is the first number. And then the last one is 2, right? We can do 3, 2, like that, right? So we need to build out our neighbors array and the indicators array, right? And then we can, after we have the indicators in the neighbors, we also need our stack, right? For 0 in degree, right? 0 in degree node. So after we build out our in degree in the neighborhood, we need to look through the in degree again, and then add the node that have a 0 incoming edge, right? The 0 degree, which is 4 here, right? And then now we are ready to start our algorithm, right? So we can start 4 at the node that have a 0 in degree, right? That would means that there's no requirement, there's no redirect to take this course, right? Right. So that we can look at the neighbors, right? Which we already built out here, right? 4, we can look at 1 and 2, and then decrement their incoming edge, right? And after that, if it is 0, we can add it back to our stack, right? So on and so forth. Okay, so let's code this up. We need to keep track of the number of course we have taken, right? Which is the number of time we are popping something off the stack, right? So we need our array, our stack array, right? So 0 in degree node, and then we need the in degree, right? We need to count, right? The number of in degree for each node, and then we need our neighbors, of course, and then of course taken course courses taken equal to 0. And at the end, we can return if the course taken is equal to the number of courses. Okay, so for each prerequisite, we have course A and course B, right? For example, right? So we need to build out our in degree. So in degree, if that is if that is course A, right? So if it is 1 to 2, right? If it is 1 and 2, if it is 1 and 0, right? Which means we need to take course 0 first before we take course 1, right? So 0 is pointing to 1. So the in degree gonna be for course A, right? So if it exists, then we can do in degrees of course A plus plus. Otherwise, we set it to 1. Right? Like this. So that is our in degree. We need to count, right? And then we need to view out our neighbors as well. So the neighbors. So if it is 1 and 0, right? Which means 0 is pointing to 1. So course B, right? And we can push course A, right? If it already exists. Otherwise, we set it to an empty the array with the default value. plus 3 equal to 4, 5. Like that. Yeah. Yeah. So after we build out our indicators, right, and the neighbors, after we count, then we need to add the node with the 0 in decrease into our array, right? So we need to start with the cores that have no redirect, right? And the node with no redirect is the node that have 0 incoming edge, or in other words, 0 in degree, right? So we just have to iterate over every single course, right? Which is already being given here, right? Num course, which means the course from 0 to num course minus 1, right? And we're gonna check the in decrease. So if it doesn't exist, right? If it doesn't exist in the in degree map, right? Which means uh, it have 0 in degree, right? So for example, right, if the readback is 1 and 0, right? Right. So we can do in degree of 1, right, equal to 1, right? But we never push 0 into our in degrees map. So it did not in the map, which means it have a 0 in degree. Okay. And then after that, we can keep going until the 0 in degrees node array is empty. So we pop off the course, right? Every time we process something, pop, and then we need to increment our course second, right? Okay. So if the course have any neighbors, so if there's neighbors, or if there's no neighbor, when we just don't do anything, right? Uh, but if there's neighbors, we need to iterate over every single neighbors, so we can pass in the course, right? You get the list of neighbors for each, right? Neighbors, and we need to decrement their in degree, and then if in degrees of neighbors uh, is equal to 0, right? And then we can push it into our array again. Right. So we pop when we process a course node, right? We're gonna pop it off, and we're gonna look at the neighbors if they have any, right? And then we're gonna decrement their in degree, right? And then if it becomes 0, then we push it into our 0 in degree array, which means it is ready to be processed, right? It is ready to be taken. So at the end, we just return whether the number of core second is equal to the number of acquired cores, right? Because it is required that we have to finish all courses or nothing. Okay, and it worked. We did very well here. So thank you for watching.